Welcome along to part 2 of this series, and now that we have done strings, Unicode and MBCS, we're now going to look at paths. But before we do, let's just zoom into the solution. I've been doing an awful lot of reading online about whether to use .h header files or .hpp. And the consensus seems to be that if you have a source file which is C++, then your header file should be named whatever .hpp. In other words, header for C++. And if you're compiling for C, then you would use .h. Now, this kind of makes sense because you can then easily recognize which header files are for C++ and which are pure C. So that is why I have gone down that particular path and started to rename all of my header files. Okay, so what is a path? In this instance and throughout, I'm not looking at UNC paths. So if you're after information on paths for webs, e.g. URLs or UNC paths, this is not it. This is purely for volumes and drives. So what is a path? Well, you should know that, but essentially it's a human readable form which points to a space or a point on a hard drive or volume. Simple as that. And it's made up a number of constituent parts. So we have a drive, the file, the extension, and then the path part. And all of those combined, as you can see up here, can be combined to give a full path. Now, years ago, we used to have DOS 8.3 file names, and this meant that when we had spaces in path names, e.g. this one here, then the space will be removed, and for example, test directory part 1 would become test (1), and this will become test (2), and so on. And yeah, that was how the volumes used to store it actually physically on the drive. But these days, short forms are no longer valid, and the reason for that is because the hard drives or volumes are able to store paths with spaces in. So DOS 8.3 short formats under Windows 10 2021, they are no longer valid. So our path is based on the active template library class cpath, which is here. And it's quite useful because it does an awful lot of heavy lifting for you when playing with paths. Specifically, canonicalize, if I get that right, canonicalize, which really does sort your path out if you've got lots of weird bits and pieces in there. It can compact paths. It's got all the old stuff in there as well. So if you're using an old drive and you do happen to have DOS 8.3 paths, then you can use the this particular class to sort it all out for you. And it also works with UNC paths as well. So it will strip off the arguments. It will split the arguments up, detecting whether it's server shares or what have you. It does it all for you, which is good. It saves an awful lot of heavy code to write. So most useful path class. So that's what we are using. So we're basing our CV path off of that. We've got the usual constructors and destructor, and we've got the streaming in operators, which means we can just keep on adding stuff to a path to build the path up. We can do things like get the specific drive label, the relative part of the path, file name, extension, all the stuff you would expect. As far as short paths are concerned, as I've just been talking about, in this particular code base, short path will return the long path, and long path will return the long path. So this is set path, which we call every time we add a new path to this particular class. And what it does, it splits the path up into its constituent paths. So what we use is split path. This is a Windows call, and it splits it up into the drive, path, the file and the extension, and we save them all. So talking about the short paths or the compact paths, notice these comments here. Windows 10 will no longer set 8.3 DOS file names on the drive, so that get short path name will always return the long path name, as this is held on the volume. So even enabling it using fsutil will only affect new files that are created. And there's also a registry setting called ntfs disable 8.3 name creation, and that refers to all of this. So the chances are, if you're using a new volume and you haven't tweaked anything and it's all been done for Windows 10, then you will not be getting the 8.3 DOS file names. Having said that, because I like to include old drives on my PC for legacy code and stuff and looking things up, then they are valid. And if I do, then I have still got the old code, because remember this is legacy code, which handles it. And this is done here. I have tried to force the conversion using a Microsoft documented hack, which is this part here. But until I found out about the this part about Windows 10, of course none of this worked. So essentially what happens is, if we're unable to find the short path name, then we'll just use the long path name, and both the class variables short path and long path will be set to long path. So yeah, these are all of the helper calls, whether the path is relative, and even if it has a short path, and we work out whether we have a short path is that we look for the tilde in the name, and if it doesn't find a tilde, then there is no short path. We can replace the drive label, can replace the file name, and replace the extension. Here's an interesting one, up, where we can go back one level. Now the weird thing is about paths is that when you're splitting a path up, if it's purely a path without a file name, and you don't end with the backslash, then that last chunk of the path becomes the file. This is something that split path does. This is not something that we do here. So essentially, if we need to go back up one level, then we need to check to make sure that the path actually has should have a double slash on the end. If it does, then if we do a reverse find, that's going to find it, which is what we don't want. So we have to remove that from the path, and then we can use a reverse find to find out where we want to split the path. And this is where we split it on the slash, and then we just rebuild the whole path up again, which is reconstitute path. We can also do a canonicalize, where the base class does the heavy lifting for us. We can add paths as well, which is basically just removing a backslash if nothing appears. If there isn't one, we add one in to ensure there is one. Then we append on the particular path, and then we rebuild all our members again, because some things might have changed. Because we can use add path to add a file name. Yeah. Add extension, we can test if it's empty or not. Now here's an interesting one, merge paths. So if you've got two paths where they could have a common point, so this is system green flow core, and this is core shaders, then if we merge them together, then they should join on core, and we should end up with system green flow core shaders source, if there was a source in here. There. So that is what merge path does. It's quite useful if you're playing with, let's say we're compiling HLSL files, and we're storing our object files in another directory. Then merge paths can be used to join things together. We have a sanitized path. Now, at the moment, you can use forward slashes in your paths, which is correct for UNC paths, and even under Windows 10, you can use forward slash or backslash, but that can make the code really complicated. So I've decided to myself that if we come across any forward slashes, they will be replaced with a backslash. So Sanitize Path will do that. It will take out all the weird stuff that happens, put it into correct format, it will canonicalize it, it will make it relative, and that is because canonicalize removes the relative part, and then we just reset everything up again. So that's about it, really. Now make relative here, and this is because I prefer to see a dot slash in front of a relative path, because to me that says the current directory onwards. But it's not really needed, it's superfluous, because if you just have a path which doesn't have a dot slash in front of it, it means the current directory anyway. But for debugging, I like to see this. So this is why I've got this make relative in here, and it only happens in debug. So let's have a look at our path test. So we've just set up some test paths here, and they're only used in the first couple of parts where we're actually looking for the various parts of a path. So we initialize, it should be empty, so that's what we expect. And if we initialize with the full path, which is this one here, then we expect to have the drive label, the file name, the extension, and the path into all their constituent parts. Other ways of setting up the path are tested too, and also a deep copy, so that if we initialize one CV path from another CV path, we expect the drive labels, file names, extensions, etc. to all be the same. So it is a deep copy. Then we check for a relativeness and what have you. Then we start adding paths to make sure that it works. Now remember what I was saying about this relative part of a path? This, in debug mode, I want to see the / in front. But in release mode, it's not needed. So we can shorten the string a little bit and make it a tad more efficient. So that's why I've got these debug bits in here. And so we go on, we add new paths of different types, and we try streaming and what have you. We try a Sanitized Path, this is where it's rather nice. So we've got a real dirty path here. And what we end up is with test. So if you work all this out, it's going through all the paths, this is what you end up with, test. So it works really well. And we have another Sanitized Path. And again, if you work all this out, you will end up with path A /test or /path A /test because it's relative. Here we test the merge paths. Now notice we have an error here and it's a false positive. That's the AI getting a bit upset. So yeah, we can merge paths. This one should fail. And if it does fail, then we expect the resultant path to be empty. So we've got a way of testing whether a merge path failed. We can replace the drive labels, replace the file names, and lastly here, up, where we go back a level, or cd ... if you will. So if we run that in x64 Unicode, you'll find that this all runs great. If we change to release mode, now we'll start seeing this side come in. Okay, so we run that, and again everything passes because /path A /path B is the same as path A /path B. If we go to x86 and run that, we should all pass again, and we do. This works in either Unicode or MBCS, so I'm not going to go through all those versions because if we look at every permutation of how we can build it, that's going to take a long time. So there you go, just a quick one on paths. Hope you enjoyed it. Thanks for watching. Catch you later.